Hello, I'm Greg, and this is the third video in my series on how to write Defender from scratch in Unity. So if you're interested in learning how to write games in Unity, grab your favorite beverage, pull up a chair, and follow along as I teach you how to write Defender in Unity. So I like to promote my videos on Discord, and there's one channel that I'm on Discord for game.ci. It's a group for doing continuous integration. Continuous integration is where you can set up your code on a repository somewhere and have it automatically build and run unit tests and things, and then deploy to different target environments, target platforms. And somebody commented on there in response to my video that they would like to see some unit tests and some continuous integration in my tutorial videos. So I'm going to shift gears a little bit before we add any new functionality, and I'm going to show you how we can unit test our code. So we're going to create a new folder under our project folder here under Defender, and I'm going to call it testing. So create folder testing, and I'm going to double click to be in there. And if we come up here to Window, General, Test Runner, you see we get this little panel here. I'm going to dock this up next to the inspector. I'm going to widen it a little bit. And you see it wants to create a test assembly folder. Now there's two different modes here. There's play mode test and there are edit mode test. Edit mode tests are great for very lightweight unit tests where you test something that doesn't have any dependency on like mono behaviors or the Unity game engine. It's great for just testing pure C#.NET classes. But I want to start by creating a play mode test because I'm going to demonstrate how we can mock our input, our user input, and how we can test. Like, for instance, in our input system, we have the ability to flip the ship over or flip direction. So we have this on flip direction pressed. So what I want to do is demonstrate how we can write a unit test to see if the ship actually flips around when that event, when that on flip direction pressed event is fired. So I'm going to click this Create Test Mode Assembly folder. And you can see, if I expand this out, it creates this folder called Test. And I'm going to call that Play Mode Test. And I actually don't want that to be there, so I'm going to cancel that. I'm going to go under our testing folder, Create Play Mode Test Assembly folder, Play Mode Tests. So that creates that. Let Unity think about things for a minute. And I'll double click to go into that folder. And you can see it created an assembly definition file. We look at that in the inspector. You can see it's got some defined constraints, Unity include test. It's pulling in a couple of other assembly definition references, so test runner and Unity Engine and Unity Editor test runner. I probably don't want this one for this particular one because we're going to be doing play mode tests only. It's also pulling in the in-unit framework. Now, in order to be able to see our code, our regular Defender code, from this unit test folder, we're going to have to actually create an assembly definition for our code, for our script. So I'm going to go into our scripts folder here. And I'm going to go up to, actually I'm just going to right click, create, and let's look for assembly definition. And I'm going to call this Defender scripts. And you can see that it has created an assembly definition similar to the other one, but we're currently not pulling in any other references. And you can see that it's broken our code. So it can no longer find the user input system. It can no longer find, well, so far that looks like the only thing it's complaining about, but it's also going to be complaining about TextMesh Pro. It's going to be complaining about DOTween. So let's go ahead and add in some assembly definition references. We click this little plus button here and open this up. I know we're going to want the input system. Let me just type input system. And I know we're going to want Text Mesh Pro. And I know we're going to want DOTween. And it's not finding DOTween. Oh, you know why it's not finding DOTween? Let me remove this here. We need to go up to the DOTween utility panel and have it create an assembly definition. Now let's see if I come in here. Oops, it looks like I lost my input system. And now we'll do DOTween. And there it is. Apply. And let's see if we can't get these errors to go away. And they do. All right, now in order to be able to do our unit test, let's go into our play mode test. And in here, we're going to want to add Defender scripts. So now it can reference our code from the unit test. We go back to our test runner. Let's create a test script. Oh, let's apply that change. And so there's a new file here, new test script, and I'm going to call this, I want to call that player ship movement test. Player ship movement test. Now, you'll notice that I'm using a very different naming convention than I normally do for our C# scripts. I want it to be clear that this is a unit test and it's not a component or a class in our game. So let's double click that and open it up, and I will zoom in. Now this first test here would be an edit mode test, which I'm just going to delete because we're not going to do any edit mode test in here. If you have the Unity test attribute, that means it is a play mode test, and you can see that it's got a return type of IEnumerator because this is basically a coroutine. And that's the way that Unity is going to run this test. It will treat it as if it is a coroutine. And so that's why we can have yield return null in here. Every time we call yield return null, we'll basically skip a frame. And you'll see how we'll be able to leverage that in order to be able to test pressing that button and seeing if the chip actually turned around. So I'll go ahead and delete this help text here. And I'll leave those using statements up there for now because I'm not really sure which using statements I'm going to want to keep. And enabled to be able to mock things and like to mock our input, I'm going to use something called NSubstitute. So if we go over here to nsubstitute.github.io, we could go look at the source on GitHub, and we're going to go down into docs and downloads, and I'm just going to take the latest one here. So if I download this, I'm going to open that. Oops, got to go find that in my downloads folder and open that up. So I drag that over here, open up this lib folder, and what we're going to want is this file right here. So let me go back into Unity. And where we have our plugins folder, like right now we've got this plugins folder here where we have DOTween. I'm just going to open this in Explorer, bring that over here, and then I'm just going to drag this guy into there and close this out. Let Unity build the metadata for that. And now you can see we've got NSubstitute right here. So if we go back into our testing folder, our play mode test, and we look at our assembly definition in the inspector, we're going to want to add NSubstitute to our assembly references and apply. And go back into our unit test here. So for our unit test, I want to create some helper files. I want to have basically a static class that can load a scene for us. So I'm also going to want to put our unit test in a test scene, so I know that things are always set up correctly for our unit test. In fact, let me do that first before I start writing code. I'll go back into Unity, and I will go down to our scenes folder, and I'm going to right-click, create scene, and I'm going to call this player ship test. And we can double click that to open it up here. And right now all we've got is a main camera, and we're going to want to drag a ship prefab into the scene. So now we've got a player ship, and what we're going to be doing with this guy is initially his direction is going to be 1, which is right, and we're going to see if our test can flip him around to point left. So now that we've got that scene, we actually have to add it to our build settings before we can use it. So I'm going to say add open scenes, and now you can see player ship test is up there. I'll go ahead and close that, save project, and let's go back into our unit test. Before I actually write any more code for our unit test, I want to create a helper class. Static class. I'm going to call it TestHelpers. And we're going to have a couple of methods in here. One is going to be one to load our scene. And I'm going to give it a scene name parameter. And it's going to start a load scene task. We're going to load it asynchronously. It's going to call scene manager. You can see that it has added the scene management namespace. So we're going to say scene manager dot load scene async. So it's going to load it asynchronously, and we'll give it the scene name. And then while not load scene tasks dot is done, we'll just yield return break or null. So this will keep running until it finishes loading the scene, and then it will let us know that it's done. All right, so after that, I want to have a static method called getPlayerShip. So you remember our test scene has a player ship in it. So you'll say game object dot find object of type player ship. Pretty simple. Okay, so now that we have that, I want to create a setup method that will load our scene and get our ship every time we run a unit test. So we're going to give it an attribute. It will be Unity setup, and it doesn't matter what it's called as long as it returns IEnumerator. I'm going to call it test setup, and we're going to say user input.instance, and here we run into a problem. So user input doesn't have a public instance field. So if we go to our user input, you can see instance is a private static variable. So we'll make this public, and I'm going to rename it to be instance. Now we have, and I'm going to move that to the top of the file since it is a public field now. And let's go back into here, and it looks like it likes that now. And we're going to finally use our substitute from the NSubstitute library. So we're going to say that instance is equal to a substitute, and you'll see it will automatically pull in the NSubstitute namespace. If your editor doesn't, go ahead and type that in manually. It's going to be a substitute for an I user input. And we're also going to want to do a yield return. We're going to call our TestHelpers .load scene. What did we call our scene? Was it player ship tests? Come back into here, go look at our scenes. Player ship tests. It is important that we spell this correctly. And we're also going to want to get our player ship. So we'll say player ship equals test helpers get player ship. And then I will have it generate a field player ship. And Unity's complaining, or the compiler's complaining, that we're trying to convert I user input to user input. So what we need to do to fix that is on our instance here, just make that an I user input. So if we go back into our test, that error goes away. So what do we want to do in our test? So this is going to be the fun part. The first thing we're going to want to do is we're going to test that our ship is not currently facing left. So initially it should be facing right because we're calling this get player ship, which is just going to go and find that player ship from our scene. So it should not be facing left already. So let's say assert R equal 1 player ship dot direction. Now that should pass and it should be true. The other thing we're going to want to do is we're going to fire or pretend to fire the on flip direction pressed event. So if we go to our user input, we have this on flip direction pressed event. So we will say user input.instance.on flip direction pressed plus equals raise event, and we want to raise an event of type action, and we have to pull in system I think that's what it just pulled in for us. I believe it was system. Yes, it's in the system namespace. Okay, so that should tell the player ship to flip around. And then we're going to wait a frame to let Unity process that event. And now we're going to test to see that it's facing left. We'll say assert R equal -1 player ship direction. Let's go back out into Unity and let it recompile all those scripts. And if we go over to our test runner, you can see we now have a unit test here. And I'm going to tell it to run selected. You see it created a test scene. It switched to our test scene, and it ran the test, and the test failed. Let's go see what it failed for. It expected -1, but it was 1. So we can say go to error line, open error line. And so this is where it failed. So apparently it did not successfully process this event and flip our ship around. So this will be good practice to see how we can debug when our unit tests are failing. So we know what we want to have happen is we want our player ship to process that event and flip the direction. So we're going to select our player ship, and we're going to go to where that event is handled. which is handle on flip direction. And this is where it should be doing it. So I'm going to put a breakpoint here. And I'm going to attach our editor to the Unity editor. And I'll go back out into Unity. And I'm going to run that test again. And we should hit a breakpoint in Rider. And it does not look like we hit our breakpoint. So for some reason, our event is not being fired in the player ship. So let's go back into the editor. And I want to go back into our player ship code. And let's put a breakpoint in on enable, which is where we would subscribe to those events. And let's put a breakpoint in on disable. Just make sure we're not unsubscribing for some reason. I just want to make sure those are getting hit. And I don't know if there's anything else that would change direction for us. But let's just go back into Unity. Actually, I want to try something. I want to see, sometimes you can run these tests from within Rider. So these are play mode test. Let me select this guy. And I will right click and say run selected unit test. And say it didn't run it. And I think it didn't run it because it says edit mode here. So let me change that. And let me try this again. And we see that we hit our breakpoint in on enable. And we are subscribing to the on flip direction pressed event on our user input. And I think I know what the problem is, but I'm going to go ahead and let this fly. And now we hit on disable, and we never got into that event handler for on handle flip. So I believe the problem is the way we are getting our user input. Right now, we're actually doing a find object of type. We don't want to do that. I think what we want to do is, well, I know what we want to do is we just want to use that singleton instance. So I'm going to say user input dot instance. So let me go back into our unit test and see if it'll let us run that again. And now we hit our breakpoint and handle on flip direction. Let's let that fly. And if we go and look at our unit test, it passed. If we go back into Unity, it passed. So there we have added a very simple unit test to just check to see if we can successfully flip our ship around, to make sure that the functionality to flip our ship around works. And I think you can begin to see how we can start to build out a suite of unit tests that we could always run whenever we make changes to see if we broke anything. So let's add a couple more tests to our player ship movement test. And let's take a look at our user input. And you can see we have these booleans here for up pressed and down pressed. That's actually going to make it very easy to test moving the ship up and down. If I had to actually test these on move received and on thrust received, I'd probably have to refactor these events. Actually refactor the event handler to when we pass these events on, to pass on the vector 2 that we got out of that instead of that actual input value. And if we get to a point where we need that granularity in our test, we can do that refactoring later. But for now, I'm just going to take advantage of these up pressed and down pressed booleans, and we're going to mock them the same way that we mocked the direction, the on flip direction pass. It's going to be pretty simple. So if we go into our test, we currently have one test, and it is, I want to rename this. I want it to be player ship flip direction test. And I'm going to copy this whole test and paste it And I'm going to rename this to player ship move up test. And instead of asserting that the player ship direction is 1, we're going to assert r equal vector3.0 player ship transform position. And then instead of setting the on flip direction pressed, we're going to say up pressed returns true. And then we're going to, instead of returning null, I want to give it a little bit more time to run. So I'm going to say new wait for seconds, and we'll just do 1/4 of a second. And then our assertion here will be is true. And we'll say that the condition we're checking is that the player ship transform position dot y is greater than 0. So we're testing to see if the player ship moved up on the y-axis. So let's jump back out into Unity. And let's run both of these movement tests just to make sure they both still pass. All right, so both those tests are passing. Let's add a move down test. So the first condition will be that the ship is at vector3.0 to start, and then we will say down pressed returns true. And we want to say that y is now less than 0. So we'll jump back out into Unity again. And we'll go ahead and run all the player ship movement tests again. I'll just say run all. And there we go. It flipped direction, it moved down, and it moved up. And all those tests passed. And so it's great that we've got unit tests that pass, but now we want to make sure that we can still play the game. So let's go into our title scene and hit play. I'm going to grab my gamepad. Hit start. I can thrust. I can flip direction. The camera panning is still working. All right, so we didn't break anything, and we have unit test coverage on ship movement. Now that we've got some unit tests working and we verified that we can play what we've got so far, I want to talk a little bit about test-driven development. So test-driven development, or TDD, as it's often called, is an iterative development process, and you basically go through a process of red, green, refactor. Essentially, you want to take your task, whatever it is you're trying to develop, and break it down into small, manageable requirements that can be described by a unit test. And then you write a test for that requirement, and it should initially fail. Actually, it might not even compile because you haven't written the code that it's testing yet. And then you write just enough code to get that test to pass. And then you go back and you refactor or rewrite the code to make it clean. And there's several benefits to test-driven development. First of all, you get, from the very beginning, you're thinking about edge cases. You're thinking about the different kind of bugs you can run into, and so you can test around that, and you can write code to handle those edge cases. And also, because you're doing the test first, you get pretty much nearly 100% code coverage with unit test, which means that you can refactor and make changes with confidence, knowing that you've got tests to cover it, and you'll know right away if you break something. But the biggest benefit, which I think, at least I think is the biggest benefit, is it forces you to write cleaner code, because the code that you're writing has to be testable. And in order to be testable, you almost are forced to adhere to S.O.L.I.D programming principles. Now, S.O.L.I.D is an acronym I won't go into great detail about it, but essentially it's a single responsibility pattern, open-close principle, the Liskov substitution principle, interface segregation, and dependency inversion. And I'll put a link in the description if you want to go read more about that. But it really helps you to write code that's easier to read and easier to maintain, and of course, easier to test. And this is what we want when we're writing a game. And I'm not going to do a whole bunch of test-driven development in this series. I just want to show you what it looks like, and then you can decide for yourself if this is something you want to integrate into your game development. So to start out, let's go and work on our test. So if we go into our ship movement test, we open that source code. I'm going to create a new class up here. Actually, before I do that, I want to move this TestHelpers. I want to move this into its own class and get it out of here, because we're going to use this from our other tests as well. And we're going to add to this. So say move to TestHelpers, and we'll go ahead and add that to source control. And I'll jump back into here, and I'm going to create a new class up here, public class. I'm going to call this mob tests. So a mob, if you've ever played Minecraft, I'm sure you're familiar with the term. A mob is basically a mobile entity, and we are definitely going to be creating mobs in this game. The enemy ships are going to be mobs. The humans that we're protecting are going to be mobs. And so I want to move this to its own file as well. So we've got that. And we're going to want to have a test setup. And it automatically added the Unity Engine Test Tools namespace. If your editor didn't, you'll have to do that manually. And we'll say public I enumerator, and it added system collections for me. And we'll call this setup test. And we're going to want to use our test helpers. Let's just copy from the other class. We're going to need to bring in our using for substitute. And do we want the player ship? I'm not sure we want the player ship in here yet. So I think instead of loading player ship tests, we're going to load a new scene called mob tests. And we're going to want a game manager, and we're going to want a human. So let's come up here and we'll say game manager, and human. And you can see those don't even exist yet. Well, human doesn't exist yet. We're going to want to grab a game manager from our test helpers. So let's say game manager, oops. That's a keystroke. I still don't know what keystroke I hit to make that happen. Game manager equals test helpers dot get game manager. And we're going to need to create that function. So let's go ahead and do that now. So I'm just going to say return game object, find object of type, game manager. Come back into here. And we're going to want to tell the game manager to start the game. And we're going to say yield, return new. We're going to wait until the end of frame. Wait for end of frame. There we go. And then we're going to get a human from the game manager. So it's going to get the human from the mob test scene. And I think, yeah, I'm not sure if I need to wait until after the end of frame to do this, but I'm just going to assume I do. So we will say TestHelpers dot get human. We'll create that function. And we will return game object, find object of type human. And that doesn't exist yet. So let's create a human. I'm going to go into Unity. And one thing I want to do is I want to take our main scene and I want to duplicate it. And I'm going to rename this mob tests. And I'm going to drag it into our test scenes folder. So I actually don't have a test scenes folder. I think I should create a test scenes folder and move both of these into it. So here under scenes, let's create a folder, test scenes, and let's just drag both of those in there. Now, do you remember I told you whenever we add a new scene, we need to go and add it to our build settings. So let's actually open that scene first. So we're in our mob test scene. We'll say File, Build Settings, Add Open Scenes, and there you can see it's in there. All right. All right, so we have our mob test scene, and we're going to want to add a human to it. So let's create an empty game object. And actually, I don't want to do that. I think I want to start with the sprites. Let's go into our art and expand our Defender sprites and just make these a little bit bigger. And scroll down. It's taking a while for it to render these. Here we go. Scroll down until we see our human. There he is. And let's rename this human. And we're going to want to add a box collider to him. Actually, we're going to add a box collider 2D. And let's double click him in the scene and edit that collider. Let's move this in a little bit, move that down a little bit, move that up a little bit, maybe move this in a little bit. That's pretty good. All right, so there's our human. I do want to move him down. And we need to change his order and layer so that he shows up in front of the background. All right, I think that looks good. And I'm going to move him. Well, I'll leave him like that for now. All right, we want to add a couple scripts to him. So let's go into our scripts folder. Let's create a new folder under here. And I'm going to call this mobs. And in there, I will create a new C# script. And I will call that human. And if I add that to our human game object, we're getting an error because we have these compilation errors. So I think what I'm going to do, instead of creating a script here, just to make sure that this guy has a human script, I'm going to say add component, C# new script, and I'm going to call it human. And so it creates it and adds it. So now he has the human script. It puts it up in the asset folder. And so we want to drag that down into our mobs. So now I want to create a prefab. So under prefabs, let's create a folder and call it mobs. Go in there, drag him in. Oh, why would that not derive from mono behavior? It does derive from mono behavior. All right, it's not going to let us create the prefab yet. We got to fix our build errors. So what is it complaining about there? well, this is wrong. Yeah, so I copied and pasted from the other class, and I copied it inside that. There we go. All right, so we've got, this should compile now. So let's go back into Unity and see if our compilation items go away. See if we can create our prefab. We can. All right. So now we need to add a test, and that test should fail because we have not written the code to make that test pass yet. So the test I want to write, let me zoom in here so you all can see what I'm doing. The test I want to write is going to be that the mob should scroll when the player ship thrusts. Because right now we got our background moving when the player ship thrusts, but we also want the mob to move when the player ship thrusts. So let's say public I enumerator human should scroll when player ship thrusts. And let's write this test. So vector 3, we want to save off his position because we're going to use this at the end to see if he moved. We're going to take the humans transform position. And that needs to be an assignment. Okay. And then we want to, we're mocking our user input, right? We're mocking our user input up here. So we want to tell the user input mock that is thrusting should return true. So Unity thinks we're holding down the right stick to the right and that we're thrusting. And then we want to wait a little bit. So say yield return new wait for seconds. We'll give him a quarter of a second just to give him time to thrust over there a little bit. And then our assertion, our condition, we want to say is true that the humans transform position dot x, and since he's facing right, we want the human to move left. The ship is facing right and thrusting forward, so the human should move to the left. And if you hold down shift for a whole long time, Windows will do that to you. All right, so I want to say that it's less than the start positions dot x. And you can add an optional message in these assert is true. And so I'm going to add a little message. So if it fails, we'll see which test failed, obviously. I'll say expected human position to be left of start position. Okay, now if we go back out into Unity and make sure our scripts all build, and we run that unit test, it should fail. So you see we have these new mob tests here. I'm going to collapse those. I'm just going to say run selected, save our scene. And we should see it load that scene, and then that test should fail. And it did. Human should scroll when player ship thrust failed. Expected human position to be left of start position. Expected true, but was false. So that's good. We expected it to fail because we have not yet written the code to make that test pass. So now, this is where test-driven development comes in. We have a test that tests the scope of the work that we want to do for this feature. Now let's go write just enough code to get that test to pass, to meet that requirement. And then if we need to, we can go and refactor things to make it cleaner. But before we do that, I saw something odd. I thought I saw 2 player ships on the screen. I'm not sure where they would come from. We're calling the game manager and telling him to start game. If you look at that, he instantiates a single player ship. I don't believe there was a player ship already in our test scene. I don't see one. But I could have sworn when I ran that test that I saw 2 player ships. Let's pause that and we'll step through a frame at a time. It loaded the scene. There's a player ship. There's our sound manager, our user input. Let's go another frame. There is a second player ship. That is really, and one of them's moving up. That's really interesting. It's not breaking anything, I don't think. Let me run all of our tests and just see if all our other tests still pass, except for this. Yeah, all those tests pass. This is the only one that fails. That is really interesting. I can debug that later. Let's work on getting this test to pass, and then we can look at weird things like that and see if we can figure out what the heck's going on there. I don't think I'm loading. Yeah, I don't know. All right, so how do we want to implement this? You might think that I would go into our humans script and put the code in here to make him scroll. But I'm not going to do that. I actually want to create another new script. Everything is a component in Unity. I want to create a new component in here because this is another feature of S.O.L.I.D. I mentioned the S.O.L.I.D principle. S.O.L.I.D means single responsibility. Every class should be responsible for one thing. So I want to have a class that's just responsible for scrolling the mobs when the player ship thrusts. So let's create a new script. We'll say create C# script. I'm going to call this mob scroller. All right. Let Unity recompile. I'm going to resize this window a little bit. So we have this mob scroller script. We'll zoom in here. And what do we want our mob scroller to do? Well, we want him to scroll the mob that he's on. We want him to scroll that position. And so we need his transform. So we're going to cache the transform. And in our awake method, we will say transform equals transform. We're also going to want access to the player ship, and we get that from the game manager. So let's say game manager, and in here we can say game manager equals find object of type game manager. And I want to add a few little helper properties. We'll have one to get our player ship. You've seen this before. We're going to use an expression body method, and we're just going to get the player ship from the game manager. And I want to add a Boolean to tell me whether I should scroll or not. So let's start implementing the scrolling feature. So we're going to handle this in update. And we're going to say, first of all, if we don't have a game manager or we don't have a player ship, we just want to return. We don't want to have any null reference exceptions. So let's say if not game manager or not player ship, then let's just return. We don't want to do anything if we don't have a game manager and we don't have a player ship. If we do have a game manager and we have a player ship, then let's say if should scroll mob. So there is another acronym. It's called stupid. So there's solid, which are good patterns that software developers use, but then there is stupid. And the U in stupid is basically, it has to do with naming, like unclear naming. So I like to explicitly name things. I could put the code in here to test to see if I should scroll a mob. And you could probably look at it and after a few seconds figure out, oh, he's checking to see if I should scroll the mob. Well, why not just say if should scroll mob, scroll mob. This makes it explicit. You can tell instantly if you're looking at this code. If I come back into this in 6 months and I want to know what am I doing in here, I just saved myself, a few seconds by being able to tell instantly what I'm trying to do here. It's just a few seconds, but it adds up. So I want to have a Boolean here that says should scroll mob. And should scroll mob is basically going to return, I just want to see if the player ship is thrusting or if the user input is thrusting. So we'll say user input dot instance dot is thrusting. All right, so yeah, if they're holding the right stick to the right, or if they're on the keyboard and they're holding down the N key, we're thrusting, we should scroll the mob. And then we want to know the scroll amount to scroll. So let's go ahead and implement this. And in here, all we're going to do is update the transform's position. We're going to take vector3.right, because this is going to be horizontal movement. We're going to multiply it times scroll amount, which we're going to calculate. And we want to adjust it by time.delta time. So let's implement scroll amount. That will be a float. And that is going to be the player ship's speed times the player ship's direction. And I think we need to adjust it, we need to flip it so that it scrolls the right direction. And I want to do a plus equal, so I'm adding it to its existing position. And that should do it. Get rid of the unnecessary using statement here. So if we go back into our test, we're saving off the human start position. We're setting is thrusting to true, so it thinks we're thrusting from the input. We wait a quarter of a second, and then we check to see if his position has moved to the left of the start position. Let's go back into Unity, and we will go into our test runner and run that test. And it failed with the same condition. Can you all guess why it didn't pass? I'll give you a hint. Let's take a look at our human. What's missing? If you said mob scroller, you would be correct. So let's go run that test again after adding that mob scroller script. Actually, before I do that, I want to override and save that change to our prefab. Now let's go ahead and run it again. Run selected. Save our scene first. And you saw him move. Now I noticed something unusual. It did pass the test, but if we were to play this manually now and use the thruster, the player is moving a lot slower than the background. It's almost a parallax, a reverse parallax effect. I need to scroll the background at a different speed than I'm scrolling the players. And the reason why, if we go into our scripts background scroller, we're just setting the texture offset. And this is not the same as moving a game object's transform. So we're going to have to actually do some experimentation and figure out, I actually want to put it on this component, not the mob component. So I want to handle the speed at which this background scrolls and try and get it to match the speed at which we're scrolling our mobs. So let's add a new serialized field here. I'm going to call this float scroll speed. And let's give it a default value of 0.5 because it looked like it was scrolling quite a bit faster than the mob. So down here, our new offset, distance to scroll, I'm going to multiply this times scroll speed. All right, let's go play that again. Okay, it's better, but it's still scrolling a little bit faster. So let's actually set this to not play maximize so I can see the scene view and see our inspector while we're playing this. So go into our background, BG Mountains, and let's bump this down to like 0.49. Oops. Let's just hit thrust. Okay, not quite right. Let's try 0.48. Did I hit enter maybe? Still not quite right. Let's try 0.475. Getting closer. 4.7. Six. Let's try 425. Okay. It's still moving a little bit faster. 0.4. Now it's moving a little bit slower. Or is it? Yeah, I think it's moving a little bit faster still. 0.39. That's acceptable to me. I don't know. I think that's pretty good. So they're not 100% in sync, but that's pretty good. Let's just run the test. Let's actually run all of our tests and see if they all pass. Alrighty, all our tests pass. So there is your introduction to test-driven development, and I am not going to do a whole lot of that in this series. I just wanted you to see what it is and how you would go about doing it, and just give a little bit of a overview of the benefits that you can get from doing it. The next thing I want to talk about is how to set up continuous integration. So continuous integration is a process where you can have it automatically build and deploy your project every time you make changes to the source code. And so I'm following the instructions from this page here. I will put a link in my description. But he's using something called GameCI, and there's a sample project up here on GitLab, which we're going to need to actually download or clone. I've actually already cloned it locally. If you wanted to download it, you could just click this and then click zip, and it will download a zip file version of that project. But after you've got it downloaded and then unzipped, we're going to be copying some files out of it that we're going to need to set up our continuous integration pipeline. So I'm just going to basically follow the steps that he did here. So he's actually creating a new GitLab project. I already have a GitLab project for Defender, and you can see I've already in my repository, I've actually got multiple branches that I've merged into our main branch. So I've got a part 2, a part 3, and a main branch. So basically what I'm going to be doing is I'm just going to be adding a continuous integration pipeline to this project that already exists. And I'm going to be following his instructions here. So if you need to create a new GitLab project, I'll leave it to you to follow these instructions here. And then we're going to follow these steps here. We actually need to copy some things from the sample project into our project. So I'm going to jump back into Unity. And I actually want to go up to the root of my folder here, and I'm going to say right-click, Show in Explorer, which will open it up an Explorer window, and I'm going to come up to the root of my project here. So I'm going to copy over the other window, which has the Unity3D GitLab CI Example. And we're going to want to copy this entire CI folder. So I'm going to right-click, drag it over here, and say copy here, and let it do its thing. Now we also, under scripts, actually we don't want to go there. We're going to go assets. There's a scripts editor folder. We want to copy that entire thing into our project. Now, I actually, in my project, if you remember, put scripts under this Defender project. And this build file, the CI build file we're going to use, won't be able to find the stuff we're copying over if I put it there. So I'm going to go back up here and just under assets, I'm going to create a new folder. I'm going to call it scripts. And I'm going to open that up, and I'm going to copy this editor folder right into there. So that gives us that piece that we need. Let's go back up to the root here. This is the other key that we need. This is gitlab-ci.yml file. This is a YAML file. YAML stands for yet another markup language. So I'm going to copy that over into our project. And if I go back into Unity, you'll see it's going to start importing all those files. And they should now be in our project. If we look under assets, there's now a scripts and an editor, and there's this build command and a build post process command. There's some magic that's going to happen in this build command. This is going to be doing a lot of the work as controlled by that YAML file that we copied over. So we can't see the YAML file from here, so we're going to have to go back into our Explorer window. And actually, let me move that off the screen, and I'm going to switch over to our code editor. And then I'm just going to drag this file into the editor so we can edit it and take a look at it. And so we want to change this to be the name of our project. I'm going to call this Defender Tutorial. We're going to have to get a Unity activation file. There's some steps we're going to have to do to make that happen. We're going to want to make sure that we set the Unity version correctly. So we'll scroll up here and we'll just add a new Unity version variable here. We'll say Unity version. And if we want to get the Unity version, we want to use the same version that we're actually building our game with. And if we go back to our Explorer window, if you go under project settings, there's a file here called project version. And if you open that up, this is the exact version that we're using. So I'm just going to copy that. And I'm going to paste that into here. I could have just gone back into Unity and then looked at this and then typed it in. But I like to copy and paste it to make sure I'm not making any mistakes typing that in. So jumping back into the source code for that YAML file, let's just take a look at this YAML file. Basically, this thing is going to handle building the game for all the different platforms we want to target. So one of the really, really cool things about using continuous integration like this is you can have it build versions of your game for every platform you want to deploy to all at once. So these are basically telling it to run these unit tests, so that's fine. But now let's look at the individual builds here. There's a standalone Linux build. There's another standalone Linux for IL2 CPP. we're not going to be doing any Linux or OS X builds. So I'm actually going to select this whole block and hit Control-K-C to comment that out. So if it's commented out, it's not going to execute that. We are going to build a standalone Windows build, and I want to go ahead and build a WebGL version too, just to show you how that works. And I'm going to go ahead and comment out Android. If you want to build for the Android, you'd want to leave this uncommented. And I'm going to comment out the iOS. If you want to build for the iPhone or the iPad, you'd want to leave that in there. And this will basically deploy your game out to a page on GitLab, the WebGL version, so you can actually play it online. And I'm going to leave that there. So we want to go ahead and commit these changes to source control. It's showing me all of these unversioned files. So basically I can just check all of those, and I could give it a commit message, and I say adding continuous integration files, and I will do a commit and push. And so that's actually going to push it all up to GitLab, which is what I'm using for my source control. And it says 18 files committed. Oh, it wants me to enter my credentials. Okay, I'm not going to do that from Rider. I'm actually going to go out and do that from the Explorer window. I'm using a plugin for Windows. It's called Tortoise Git. So let's go over to my taskbar here and find that window. All right, I'm going to come up here to my Unity projects folder, and I'm going to right click and say git commit main. And it's already done a commit, so all I got to do is push. So I'll say tortoise git push. And there it wrote them all up to GitLab. All right, so now let's switch over to our GitLab project in the browser. Go look at our repository, and you can see I added the continuous integration files 1 minute ago. And if we jump down here, you can see it actually tried to run a job to build that project. But it can't build it yet because we're still missing some things that we need. And so what are the things that we're missing? If we go back and look at these steps, we got to add some variables for our password and username. The build needs our Unity credentials in order to build the Unity project. So we're going to add them through variables so that people can't steal our credentials. If we put them in our actual script file, somebody might somehow get access to it and be able to steal our credentials, and we don't want that to happen. So under settings, there's a CI/CD tab here. And if we go down here, there's a variables section. So we want to expand this, and we currently don't have any variables. So we're going to add 2 variables. We're going to add Unity username, and you want to watch me type that in, don't you? I'm going to move that over off screen, and I'm going to type in my Unity username. And then I'm going to add one for my Unity password. And if I drag this back here, you can see I now have a Unity username and a Unity password variable that the build can use to build our game. So the next step is to go back up here to our pipeline where it was blocked. And we want to tell it to get our activation file. We're going to need this so we can get our license. And so it is starting to run a job to do that, and it has to spin up a Docker instance in order to be able to do this. So I'm going to pause the video, and I'm going to come back after this is finished running. Okay, so that finished running, and it took 3 minutes and 44 seconds. You'll see there are some instructions here that we need to do to finish getting our license set up. So we want to download the artifact, which should contain this .alf file. So if we go to our artifacts and click download, it's downloading an artifacts.zip file. And if we open that file, there it is, our Unity3D.alf. So I am going to just extract that out to the downloads folder. And then it wants us to go to this link here. So I'm going to open that up in the browser. And it wants us to upload that file. And now it wants me to download my license file. And there it is. So go back to our instructions that we were looking at. That looks good. We need to copy the contents of that file into a new environment variable called Unity License. So from here, I'm going to go into Settings and CI/CD and go back to Variables. And we need to add a new variable called Unity_license. And I'm going to move this off screen. And basically, I'm going to open up that that file that we just downloaded in Notepad, and I'm going to copy the contents of it and paste it into the value of this environment variable. And then I will drag this back into here so you can see I now have a Unity license variable. So now we're ready to try and rerun our pipeline. I could, if I wanted to, do another commit to source control. So if we were to make another change to our game and then push those changes to source control, it would automatically rerun this pipeline. But you can also manually run your builds by just clicking Run Pipeline, and I'm running it against the main branch. And we will let this build run, and you can see it's going to build a standalone Windows and a WebGL, and is going to run our edit mode test and play mode test. Now we don't have any edit mode tests, but that's fine. So this job has kicked off. If we were to open this up, we could actually see the steps and stuff that it's going through. This is going to take a while. So we are going to have to, that says that finished already. Oh, that was just one step of the job. Yeah, so you can see that all these steps are running. I'm going to pause the video and I'm going to come back when these have completed running. So it's been over 25 minutes. These builds finished fairly quickly. The WebGL build is still going, but I wanted to take a look at our play mode test. It says that this job failed. You can see we had 6 tests, it says. I think it's including these edit mode tests that don't exist. But if we go in here, you can see that it says, well, there's a problem uploading an artifact. But I saw higher up that it said that some of the tests failed. Yeah, here we go. Run succeeded, some tests failed. So if you go up here, it says run succeeded, some tests failed. So I'm going to go back to our CI/CD, go back into here, and I want to go into this test tab here. And this can show you, oh, so there are 2 sample edit mode tests, I guess, that it ran. But here we have our 3 play mode tests, or 4 play mode tests. It says 3 of them passed, but 1 of them failed. And if we click on the failed one, it tells you that the human should scroll when player ships thrust test failed. And it failed after 3 minutes. So you see these all ran in like less than a second. This one ran for 3 minutes. And if you look at the details, it timed out. So it apparently has a limit on 3 minutes for how long it's going to try to run a test. So for some reason, this test, when it was run in the continuous integration environment, never finished. So we're probably going to want to take a look at that test sometime to see why the continuous integration version is not working. And apparently Corel Painter wants me to update to a new version with some Black Friday deal. So I will pause the video again and we'll wait for this version to finish. And as you can see, the WebGL build finally finished after 41 minutes of running. And I don't really expect these builds to actually work correctly. We never really configured these builds. So we go back into Unity and we go into our build settings. There are lots of settings that you can configure for each environment. And I haven't really gone in and paid attention to what I've got configured for these. So I would be really surprised if I actually booted these up and tried to run them and they actually worked, especially the WebGL build. There's some things around the resolution and also compression and stuff that you got to make sure is just right, or it won't be happy when you try and run it in your browser. The other thing I noticed, and I'm not sure why, it did not appear to do the deploy step. So in the example that I was following, there was another stage. So we got prepare, build, and test, and there should be a deploy stage, which would have pushed the WebGL build, which would have pushed the WebGL build up to the GitLab pages. I'm not sure why that didn't happen. If we go and look at my YAML file, we go to the top, we've got the three stages: prepare, build and test, and deploy. And then down in the bottom of the thing, under here, we have pages, which is part of the deploy stage. But this never seemed to execute, and I'm not sure why. I've actually posted a question to the GitHub page. I'm sorry, the Discord channel for the GitLab CI. But we will revisit that probably in a future video. I don't want to go any farther with this. I think this has been a good introduction into unit test, test-driven development, and continuous integration. So I think I'm just going to wrap it up there. Well, I hope you found all that useful. And if you did, do me a favor and click the like and subscribe button. It really does help me to grow my channel. And if you have any friends that are interested in game development that you think might like tutorials like this, share a link to my channel on your favorite social media platforms, Facebook or Twitter, Reddit, Discord, wherever you hang out and talk about game dev stuff. And in the next video, we'll hopefully get back to implementing some more functionality of Defender. I know I took a little bit of a detour in this episode, but I hope it was useful. And in the meantime, thanks so much for watching and good luck on your game development journey.